Hi everybody, it's Miss Austin and I'm going to be going over the Unit 4 Lesson 6 practice problems. Number 1, a population of 1,500 insects grows exponentially by a factor of 3 every week. Select all equations that represent or approximate the population P as a function of time in days T since the population was 1,500. So you could look at the choices and then decide, or you could just try to write the rule yourself. I mean, we know the starting number is 1,500. They're all good. We know it's growing exponentially by a factor of 3. So they all have 3. So that's not helpful. Now, the time is, they were tripling every week, but they want us to write the rule so that we can figure out how much it increases per day, right? So we're going to have to take the normal equation that they gave us, right? That's a week. But they want us to write it in days. So we're going to have to break that down. How many days in a week? 7. So, and there's 2 different ways to write it. You could say T over 7, right? So this would be, if I put a 1 in there, that would stand for 1 day. 1 out of the 7 days of the week. 2, that'd be 2 days. Now, do I see that answer over there? I sure do. That's not right. That's telling me per week. That is not correct. We don't raise it to the 7th, no. And then is this one also the same? This one is also the same. It's another way to think of breaking it down per day and then multiplying it by the days. So if I know that T is normally a week, then I want 1/7 of how many, and then T stands for how many days I want. So if I want 3 days, then I would put a 3 in here, and that'd be 3 times 1/7, which would turn it into 3/7. If I want 4 days, I'd put a 4 in. So this is just showing this sort of deconstructed. The 1/7 is per day, and T is the number of days. You can remember your exponent rules. I just want to show you that real quick so you can understand why. When you have a power being raised to another power, you can technically, well, the rule is, you can multiply these two together. So that's 1/7 times T. There's a 1 under that if that helps. So this is actually T over 7. So you can see that those are actually the same thing. Okay. Number 2, the tuition at a public university was $21,000 in 2008. Between 2008 and 2010, the tuition had increased by 15%. Since then, it has continued to grow exponentially. Select all statements that must be true. All right, let's just go through these. The tuition cost can be defined by the function f of y equals 21,000 times 1.15 to the y over t, where y represents years. Okay, so let's see if everything lines up. 21,000 starting. Yep. If it's increasing by 1, remember your growth factor is 1 plus the rate. So it's 1.15. Yep, that's good. And then the growth rate was 15% over 2 years, right? And they're saying this one is per year for a single year. So see how they took and they put y over 2. Because if you put a 1 in, that would only stand for 1 out of the 2 years that this 15% was the growth rate for. Okay, so that's good. The tuition cost increased 7.5% each year. Okay, so let's talk about how you figure this out. They told me this was the growth rate for 2 years. Well, if I want to know just for 1 year, then I take that to the 1 out of 2. I want to know how much the growth rate was for one single year out of the 2 years that this was calculated for, which they keep driving this home. That's the same as doing this, right? Either way you want to type it into your calculator. I'm probably just going to do the power. 1.15 to the, I already got it, 0.5, or So that's 1.072. Let me write that down for a second. Is that a 7.5 increase? No, that's a 7.2% increase. So that one's wrong. And that was very nice because look at the next one. It says the tuition costs increased about 7.2% each year. Yes, that's the correct right answer. I took the growth rate for 2 years and raised it to the 1/2 power because I only wanted one out of those 2 years, and I got that. 1.072. That's the growth rate right there, 7.2%. The tuition cost roughly doubles in 10 years. Well, you could do the whole equation and see if you get, about double this. I was thinking I would just kind of do what I did here, because if the tuition is going to double, that means the growth rate's got to be about 2. So I'm going to take 1.15 and I want 10 years. So 10 over 2, right? That's the equation. Y stands for the number of years. If I want 10 years, 10 divided by 2 is actually 5. So I'm going to do 1.15 to the 5th. See what this turns into. 2.01. So pretty close to 2. The growth rate for a 10-year period is 2, which means double. I'm going to put yes. Yes. And last, it says the tuition cost can be approximated by the function f of d equals 21,000 times 2 to the d, where d represents decades. Okay, well, we just answered on letter D that it does double in 10 years. So does this rule work? We've got the starting amount. We figured out our growth factor. It was doubling, which is 2. And that was every 10 years, which they're saying right here is D, which stands for a decade or 10 years. Yes, this is another way to write the rule. All right, number 3, here's a graph that represents g of x equals a times b to the x. Find the values a and b, show your reasoning. So, well, first of all, hopefully we know that this a is my starting amount, 10. So g of x equals 10 times b to the x. I need to figure out what my decay rate is. I know this is decay because it's going down. Now, it might help to kind of look at it in table form. So I'm going to go like this, 0, 10, and I'm going to leave some space in here, okay? And then 1.5, I have 1.25. Now, those are the only pieces of information they give me, so I have to use those, okay? So if I want to figure out what I multiplied to go from here to here, right? Most people can't look at that and figure that out quickly, so just take this number and divide it by this. So I get 1.25 divided by 10. I guess we probably could have done that one. 0.125. Right? But that's over 1.5. So I need to figure out, right? Our goal is to figure out over an interval of 1, not 1.5. So there's a couple of different choices you could do here. You could, right now, if I write the rule, g of x equals 10 times, whoops, sorry, I meant to put the answer in there. 10 times 0.125 to the x. This is standing for every 1.5. Usually when you write a rule, you want to write it for every 1. So what I'm going to do is I'm going to figure out what our decay rate would be for 1 year. This is for 1.5. Okay. So I'm going to go over here. Right. I'm going to make the denominator 1.5. Right. But I only want 1 out of the 1.5 years. So now I'm going to take this and raise it to this power right here. And that should give me the decay rate when I increase x by an interval of just 1 instead of 1.5. So here we go. 0.125 to the 1 divided by 1.5. 0.25. So that's the decay rate. That's what I want for B. So my final answer is y equals 10, that's A, times 0.25 to the x. That's B. Now, if I want to make sure I did it right, okay, that stands for one interval of 1. I'm going to see if I type this in and put a 1.5 there, right? Because I want 1.5 to make sure I get this answer right here to make sure the rule works. Let's check. 10 times 0.25 to the 1.5, and I get 1.25. Now, another way you could think of that, if this is sort of confusing to you, come back over here. And I was thinking of, you go 1.5. So think of it in halves, right? This jumped 1, 2, 3 steps. But I wanted to know the the decay rate for just 2 out of those 3 steps. So you could have also done that 2/3 instead of the 1 over 1.5. You still would have got this, whatever makes more sense, okay? So even though this is what we calculated for the decay rate, that was over an interval of 1.5. We wanted to know the decay rate for an interval of 1. So I took what I got over the interval of 1.5 and then raised it to the 1 over 1.5 because I wanted to know the interval of 1. All right, moving on. Question number 4. The number of fish in a lake is growing exponentially. The table shows the values in thousands after different numbers of years since the population was first measured. By what factor does the population grow every 2 years? So look, from 0 to here, hopefully most people can see that I'm multiplying by 4. Okay, that's the factor. 4 every 2 years. Use this information to fill out the table for 4 years and 6 years. Okay, so now if I jump 2 more years, I'm going to do the same thing. I'm going to multiply by 4, so I get 160. 2 more years, do the same thing, multiply by 4, it's 640. By what factor does the population grow every year? Explain how you know and use this information to complete the table. Now, you might be able to think this one through maybe a different way than what we've been talking about, but I want to emphasize the way we've been doing it. If this is the growth factor for every 2 years, and I want to know every year, right? So this is normally the growth factor. But I want to know, and that stands for every 2 years. So I'm going to make a 2 on the denominator, and I want to know just 1 out of those 2 years, right? So that's going to be 4 to the 1/2. Hopefully you already know what that answer is, right? Remember, that's the same thing as the square root of 4. If that's helpful to think of it that way. 4 to the 1/2 is 2. So every year, its growth factor is doubling. Every 2 years, its growth factor is quadrupling. Again, this might be one that you could figure out without thinking of it this way, but I wanted to emphasize how we take that exponent and we break it down. Okay, so that'd be, now let's go figure out this. Every year it doubles. So that's 20, that's making sense. That's 80, that's making sense. That's 320, it's making sense. All right, number 5, the value of a home increases by 7% each year. Explain why the value of the home doubles approximately once each decade. Okay, so if something increases by 7%, then the growth rate is 1.07, or the factor, okay? That's every year. They don't give me a variable. I'll put T for years. They want to know, what would the growth factor be for a decade? So I'm going to write I'm going to put a 10 in there. I want to do that 10 times. So 1.07 to the 10th, right? Because technically this is just, if I put a 1 there, that stands for 1 year. And I want 10 of those. So I'm just going to type this into my calculator. Oops, not my phone. And I get 1.07 to the 10th. And it's about, you know, if we rounded 1.97, I'll use my approximate symbols. So yeah, is that pretty close to doubling? Yes. Because, so it says explain why, because 1.07 to the 10th power is almost 2. Why did we put a 10 in? Because you're multiplying by 1.07 10 times. One time for every year. Which, yes, approximately doubles. Okay, pretty close to 2. All right, last one, number 6. The coordinates of A are 1, 4, 3. The coordinates of B are a half, 4.5. And if the x coordinate of C is 7/4, what is the y coordinate? Okay, well, we're going to have to figure out the growth rate. And they do give us 2 points where we can figure that out. Okay, so again, I'm going from 3 to 4.5. What am I multiplying by? If you don't know, take the number after and divide it by the number before. 4.5 divided by 3. The growth factor is 1.5. And that is for every, now let's look. Now we might want to make, I might make a table to help make sense of this. 1/4, 1/2, 4.5. So that growth rate of 1.5 occurred over an interval of 1/4. Okay. So technically, if I put, you know, make a rule out of this in a way, so I'm trying to figure out this y coordinate. If I put, let's just put a t in there. This stands for every quarter hour. It grows by 1.5. Okay, well, I want to know how much it's going to be once it gets to 7/4. Well, I need to pick a starting point. I could start at 1/4, 3, or I could start at 1/2, 4.5. Wherever I start will just depend on how many times I'm jumping to get to this point right here. So I'm going to start at the very first one. It just kind of seems logical. So I know the starting amount is 3. I know that's not my y-intercept, but I'm not going to figure that out. I'm going to go from right here. You can do this, okay, since it didn't ask for the y-intercept. And then I know the growth factor is 1.5 to the t, and t stands for a quarter of an hour. Okay, well, I want to figure out how many quarter hours until I get here. Now, you might be able to figure this out in your head. I'm going to show you over here, right? You go 1/4, a half, 3/4, and 1. I'll kind of separate these so you can see them. And then you would go 1 1/4, which is 5/4. Uh-oh, Miss Austin's running out of room. 6/4, and finally 7/4. So if I'm starting right here, how many 1/4 time intervals is that? 1, 2, 3, 4, 5, 6. So I'm going to take this rule that I wrote, right? So starting at the number 3, I know every quarter hour it grows by 1.5, and I need to do that 6 times. So now I'm going to type that into my calculator. 3 times 1.5 to the 6th power. So the y coordinate is approximately 34.2. Now I want to show you, you could also, just to show you that it doesn't matter if I started with that point, I could have done this one. Watch. If I said 4.5 times 1.5 to the t, so now I'm starting here. So if I'm using that as my starting number, how many times am I jumping until I get to 7/4? So I'm only going 1, 2, 3, 4, 5 times. So I put a 5 in here. Since I started at point B, I only had to go 5 intervals of 1/4, and you're going to see that you're still going to get the same answer. So 4.5 times 1.5. This time I only need to jump 5 times, 34.2. Okay. All right, I hope that helped, and I'll see you soon.